The year was 1995. Parkes Observatory in rural New South Wales, Australia. Radio astronomers there were hunting for something extraordinary. Black holes collapsing in distant galaxies, millions of light years away. Their equipment was cutting-edge, sensitive enough to detect whispers from the cosmos. But something kept going wrong. Every single day, their instruments picked up bizarre interference. A signal appearing and disappearing randomly. It had no business existing out here, in the Australian outback. The astronomers checked everything. Power lines, nearby equipment, even aircraft. Nothing explained it. And it wasn't just annoying, it was contaminating their data. Years of black hole research, potentially ruined by this phantom noise. They called it a problem. Nobody wanted to solve it. Until one engineer, frustrated and curious, decided to investigate anyway. That choice would accidentally change how the entire world connects. Australia, early 1990s. CSIRO's Radio Astronomy Lab. John O'Sullivan and his team had one deep obsession. Listen to the universe. They were hunting black holes, objects so dense and extreme they bent space and time itself. But to detect them? Nearly impossible. Radio signals from black holes traveled billions of miles through space. By the time they reached Earth, they arrived mangled and corrupted. Cosmic noise, Earth's radio interference, background equipment hum. All of it mixed together into the genuine whisper from deep space. They needed to separate signal from total chaos. A mathematical trick nobody had invented yet. Every standard filtering method failed completely. Too much noise drowning the signal. The team was stuck. And they had absolutely no idea their solution would rewire how the entire world connects. By the early 1990s, radio interference was everywhere. Microwave ovens, radar stations, cordless phones all screaming across the same frequencies astronomers needed. Parkes Observatory wasn't just receiving noise. It was drowning in it. Every single observation corrupted. Every signal suspect. The phantom wasn't occasional. It was constant. Relentless. Their black hole research was completely paralyzed. They couldn't trust a single reading anymore. Decades of telescope investment, rendered nearly useless by this invisible wall of static. The problem wasn't theoretical anymore. It was existential. Either they understood this interference and eliminated it, or the entire project died right here. The stakes flipped overnight. They weren't hunting cosmic mysteries anymore. They were hunting the noise itself. Stackpole assembled his team with a new mission. Decrypt the phantom signal. Map it. Understand it. Beat it. The black hole search could wait. Survival couldn't. Then someone asked the right question. What if we stop fighting it? What if we spread the data across all the frequencies at once? One engineer realized something elegant. Send the same message simultaneously on 10 different frequencies. Even if interference blocks 2 or 3, the others get through. The signal actually becomes stronger. More than that, it's unbreakable. You can't jam a transmission spread across hundreds of frequencies. You need to jam everything at once. This was spread spectrum technology, military innovation, designed for battlefield radios that couldn't be intercepted or jammed. But it had an unexpected side effect. In noisier environments, you could pack more frequencies safely. What killed every other communication method made this one stronger. By the late 1980s, someone had a realization. This could work in the industrial frequency bands, the ones everyone else had simply abandoned. The frequency spreading trick had a name: spread spectrum. Nobody in radio wanted it. It looked like noise. It looked broken. In the early 1940s, a small team of researchers realized something radical. When noise moves, when it changes frequency constantly, it can't be jammed. It can't be intercepted. It simply can't fail. They patented the idea. The military took notice, studied it, then moved on. Decades passed. The technology faded from memory, cast aside by those who once rejected it. Then someone asked the critical question: what if we use this for wireless data? For consumer products? The answer was Wi-Fi, the 802.11 standard born in the 1990s. That spreading technique, abandoned, dismissed, left for dead, became the skeleton key. Millions of devices could share the same airspace without interference. No wires, no cables, just invisible waves, disciplined by a discovery from the 1940s. By 2011, Qualcomm and Apple weren't even invented when CSIRO patented this. Their team was just listening for whispers from the cosmos. Yet that same tech now moves 14 billion devices. Every iPhone, every laptop, every connected home. In 2011, their patent was worth $7 billion. But here's the twist nobody talks about. CSIRO nearly let it expire. They almost gave away the most valuable accidental discovery since penicillin. No la hice sin fees. No revenue. The patent survived by months. Today, that same technology sits in your pocket. It started with a black hole mystery. It ended with the invisible backbone of modern life. An observatory in Parkes, Australia. Scientists just trying to see farther. That's how the world got Wi-Fi. Not from engineers designing the future. From astronomers solving the past.